In this video, we will look at example 1 in sections 3.1, 3.2 on using derivatives to identify extreme values. So let's let f of x be the function x to the fourth plus 4x cubed minus 10. In part A, we want to find all intervals on which our function f of x is increasing or decreasing. So just recall that our function is going to be increasing where the derivative is positive and decreasing where the derivative is negative. So this means that our function will change from increasing to decreasing or decreasing to increasing where the derivative is equal to 0. So this is where the function changes from increasing to decreasing or vice versa. So in order to get started on this problem, we need to compute the derivative f prime of x. So please pause the video right now, work out the derivative of our function. And when you're ready, we'll compare answers. All right, so we just see that we just need to use the power rule here. So we get as our derivative 4x cubed plus 12x squared. Done, that's it. The 10 just goes away. Derivative of constant is 0. So now we need to check where the derivative is equal to 0 to find the places where f changes from increasing to decreasing again, or vice versa. So we need to find where f prime of x is equal to 0. This means we need to look at where 4x cubed plus 12x squared equals 0. So notice here on that left-hand side that we can factor out an x squared from each term. And in fact, we can do better and factor out 4 from each term as well. So then this just becomes x squared plus 3 all times x squared. We want to know where is that equal to 0. And I hope you caught the error I made. This is actually a 3 when we take that derivative. So this is going to be just x when we factor out an x squared. Okay, so now this gives us 2 results. So this means that x plus 3 could equal 0, or let's clean up a little bit more of these errors. I factored out a 4 also, didn't we? 4x squared. Okay, let's just double check. Yep, that looks good. And so then we also get 2 situations when x plus 3 is equal to 0, or when 4x squared is equal to 0. So in that first situation, that means that x is equal to -3. And in that second situation, x is equal to 0. So we have 2 solutions for where the derivative is equal to 0. So now what we do is something called a sign chart. We want to set up a sign chart. So I'm going to even write that down for us. So now we set up, let's get that shape supporter out of the way. We just want a freehand here. Set up a sign, like plus or minus chart. So what does that look like? Well, what I want to do is create a table here where I label my 2 places where the derivative is 0. And then I want to look for what the sign of f is on the in between -3 and 0, and on either side. So now we need to pick a point in each of these chunks of interval to check or compute the sign of the derivative there. By computing the sign, it will tell us if our value or if our function is increasing or decreasing. So let's look at some test points. So we could test, say, -4, we could test -2, and we could test something over here like 1. So now what I want to do is compute those values of the derivative. So f prime of -4 f prime of -2 and f prime of 1. So go ahead and compute those values for us. One suggestion I'll have is, we don't actually need to compute those values. We just need to know the sign of the derivative at those values. So we see that we can rewrite that derivative just to simplify things as that x plus 3 times 4x squared. So we can go ahead and plug -4 in there. So we get -4 plus 3 times 4 times -4 squared. So notice this term here, -4 squared, that's positive. This term here, -4 plus 3 is -1. So we have a negative times a positive. So this whole thing is going to be negative or less than 0. So I'm going to put negative in that interval on the left here. Checking the derivative at -2. So I have -2 plus 3 times 4 times -2 squared. What happens here? -2 plus 3 is a positive 1. -2 squared is a positive. So I get a positive times a positive. So I get a positive result in the derivative. And then finally checking f prime of 1. So I have 1 plus 3 times 4 times 1 squared. So I have a positive. 1 plus 3 is positive. 4, 1 squared is positive. So I get positive times a positive, which is again a positive. So now we see that our function is decreasing on this interval and increasing on this interval. So let's go ahead and write that out. So we will use this space down here, that f is decreasing because the derivative is negative on the interval from -infinity to -3. And now we're not going to include this 3 in our interval because at 3, our function is plateaued, right? Our derivative is 0. So we don't increase or decrease there. So that's why we don't include that endpoint. And then f is increasing on the interval from -3 to +infinity. We don't need to disrupt this interval by using 0 here, even though the derivative is 0, because all along it, our derivative is positive, which means our function increases. All right, so then our solution for this first part A is that f is decreasing on the interval from -infinity to 3 and increasing on the interval from -3 to infinity. So to finish this video, let's look at part B. Then we'll break it up here so that the part C is its own video, so it gives you a break in watching. All right, so I'm going to erase my work a little bit, make sure you have all your work recorded, and then we'll look together at part B. All right, so part B says find all local maximum and local minimum values of f of x. So to do this, we can refer to the sign chart above. So we see that the critical values occur at -3 and 0. And what we also notice, and I'll make sure we record this so we can follow along. So critical values. So those are possible min or maxes occur at the critical values. We don't have a closed interval that we're computing our function over, so we don't have endpoints we need to consider. So we see that at x equals 0, our function is increasing. So that means we have no local max or min. So what we need to do is just check at x equals -3. So how do we check that? Well, we could notice a few things. So notice that the derivative is negative to the left, and the derivative is positive to the right. So the first derivative test, we could draw that out. So negative on the left, so we're decreasing, positive on the right, increasing. So at x equals -3, we have a local min. And so we want to know maybe what is that local value, because we want to know the values of f of x. So now we just need to compute that value. So let's go ahead and clean up here. Make sure that you're recording your work so that you can follow along and look back at your notes. So now we just need to compute the function value at -3. So if we plug in -3 to our original function, we are going to get -4 to the 4th plus 4 times -4 cubed minus 10. And when you do all that work, we should be getting -37. So -37 is a local min. Awesome. All right, great work on this first part of this example, everyone. And I'll meet you in the next video to finish up part C.